All right. All right. So why do cities vary in size and scope? So this is distributions from 2000, from a while back. But population greater than 10 million. 2. This is the United States. What 2 are we talking about?
New York City.
New York City, bingo.
Los Angeles.
Los Angeles. That's it. Cities over 10 million, those 2. And then we start to see, okay, there's a handful in the 5 to 10. And then boom, we get into 43 in this 1 to 5 million range, right? So the question is, why don't we have a bunch of other cities, like a lot of big cities or little ones? Why do they take on this distribution of population? And so this chapter is going to look at that decision. So localization and urbanization economies increase productivity and wage. What's productivity? Number of outputs per unit of input, or number of outputs divided by number of inputs, which is output per unit of input. Okay, so let's see what's going on here. We've got a workforce, and it's growing from 1 to 2 to 4, so it's doubling each time, right? So we got 3 different workforces that's doubling. And then we've got wages. Would we expect wages to be going up from what we've done in the past? With city size, cities getting bigger, we said the businesses agglomeration is going to trickle into the wage. So then we've got our labor income. So that's looking nice for people. And then we've got commuting costs. Is that helping us or hurting us? Hurting us. Okay, so what's going on with utility over here? One of the reasons I asked that is we got a dollar sign. Is utilities dollars? Yeah, it's not. So it's utils, which I always hated that term, but it's units of happiness, whatever that means. That's different among individuals. So you can, basically we do this with the demand curve, right? Is that, well, what's the benefit of the 3rd slice of pizza? Well, we can look at how much are you willing to pay for that 3rd slice of pizza, and that reveals your benefit. So there is a connection. That's why we call this the marginal benefit curve, which then became our demand curve. So there's a connection there with utility being measured in dollars. So don't let that throw you too much. It's still conceptually similar to what measuring happiness. So 59, 70, 66. What's going on? That's kind of weird numbers.
It looks like it's labor income minus commuting costs.
Okay, labor income minus commuting costs, right? So this is a bad, this is a good. And so we've got 88 minus 22 equals 66. So what's really going on here in terms of the numbers? As the city grows, tell me about the competing forces that are going on. Takes longer to get to work, so in congestion, in traffic, so the anger factor. So we got an increasing cost with commuting. But we also have an increasing wage. So we have kind of an increasing cost here, but an increasing wage. So it's like, I want to move to the city. I really hate traffic, right? So we've got kind of the 2 things. I got big bucks I can make in the city, but I got to deal with traffic. All right, so leisure is our good that we usually think when we're not working, we're enjoying leisure, whatever that looks like for you. So the labor-leisure trade-off. And so we might have more opportunities, as Eddie was saying, for leisure in the city, because there's more things to be able to do. Okay, so 8-hour shift. I don't know if you guys picked that up here. Did you get that? All right. So 88 bucks on an 8-hour shift. And so this is indirect utility that we don't have to worry too much about. We just have to kind of not be weirded out by a dollar sign. So this creates this graph. So there's your 59, 66, and 70, different levels of happiness. And as the city grows, we get to a point where, oh, I like moving to the city, it's good, and then, oh, the traffic sucks in LA, right? So we get to that point, and we want to think about where cities are going to stop. Why are some cities bigger than others? Why are they smaller with this U shape? All right? So here's our equilibrium concept. So differences in commute costs are offset by differences in land rent. Is it expensive in the city to live downtown? Yes. If you haven't ever checked prices, it starts to go up with the price of that. So we're going to make an assumption with this model that we've got these equal shares of land rent. So rent is going to be paid depending on how, the further out the land is cheaper, closer into the city. If you're right in the city, your commute distance is 0. And then you've got your utility is equal to your labor income, rental income, minus commute cost, minus the rent paid. So now we're starting to have a number of different factors here to get us into how much we're paying in total. So why are we doing all that? Let's take 3 cases. So we've got 6 million workers in a region among cities in 3 regions. 6 cities with 1 million, 3 cities with 2 million, or 2 cities with 3 million. So we want to kind of think what's going to happen in those cases if we think about utility now. So if we're in a city with 3 million, we've got the 2 cities of 3 million. Let's think about what happens if we move. So would they be wanting to move? What happens? So if people move to the other city, it gets bigger. Do I get happier or sadder? Sadder. So utilities going down as we move this way. And then when you leave the other city, if we're on this side of the utility curve, when you leave the other city, what happens to the people who are currently in the city? Are they happier or sadder? They're happier because what? It's shrinking and there's less commute, right? Once we've gotten to this point where we're over the utility hump, then if it gets smaller, then our utility per person goes up. Now, with that in mind, what would likely happen as there's movement this way and this way? Would that remain? Is that a stable outcome to have 2 cities do that? Because if that city's looking happier, oh, there used to be so much traffic, but now it's not, what would they tend to do? They go back and converge. So we tend to see cities would be on this side of the utility curve.
So you kind of have like a entry.
Kind of an entry-exit thing, yeah. We're using utility as the thing that's going to drive people from one place to the next. Okay, so what do we mean by it's self-correcting? Changes in population are self-correcting. Are going to go to the happy city, right? And so we won't have that divergence with these 2 cities for the reasons we just went through. So it's a self-correcting kind of market mechanism the way it's designed. Now, what about cities on the small end? So now we've got 6 cities of 1 million. What happens if cities are too small? Cities are not too small. What does that mean, not too small? Go through that same thought exercise now with the small city.
Too much space. Not enough things to do.
No, tell me from this model. I'm not asking to think kind of, about stories or something, but actually using this model. So this is the utility function. We just did the one where we were over here, and I kind of want you to do that same thought exercise. So we have 6 cities now, 6 cities of 1 million, got 6 million people in a region. We've got 6 cities of 1 million. What's going to evolve over time?
It'll become one.
No, it won't become one.
So like.
Yeah, tell me about one of them. Tell me about, like, do that the same thought exercise I just did, Nate.
One city's gonna get bigger to 2 million.
Okay, so if one city, if people start to leave, go ahead.
Yeah, because at the 1 million right now, if people move out of that city and get smaller, it's gonna bring the utility down. But if they move to a growing city to attract more people to that growing.
So all it takes is one person out of the million. And now we've got a population of 999,999 and 1,000,001. What happened in terms of the small city? Did it become happier or sadder? Sadder. The one with 1,000,001 became happier. And so now what's one other person in the sadder community thinking?
I need to go to that.
I need to go to the happier. So now that person leaves. And all of a sudden, we're doing this. What's going to happen to the shrinking city? What's it going to shrink to? Zippo. So it's going to disappear, and people are going to move to the big city. So one city is going to continue to grow and mature, and so that's going to end up heading down to this type of path. Now, let's say we're at 2 million. Let's say that one city, just kind of hypothetically starting from somewhere. So that one city now is at the peak here. I don't know if that's exactly the peak. So let's say it's at the very peak. Graphically, I'm not sure it is, but let's say it's at the very peak. And do that same thought exercise. The one city disappeared, and we got 4 other cities now, right? Or
5 total.
5 total. 4 are all at 1 million. One's at 2 million. What's going to happen to one of those? Where do they want to live?
Right now they're gonna live in two.
They're not gonna move to 2 million because that's the peak. So if one of the
Okay, are they not going to? I want to make sure of that.
I think they don't know that it's the peak, so they're gonna try to move to 2 million and then realize that it's not actually that good.
What? Whoa, you might be jumping the gun there too. You were doing good, and then you kind of kept talking.
So they might move to the 2 million, but the people that are in the 2 million are happy, so they'll move to one of the other 1 million.
So if you're in the 1 million, how much is your happiness? Using these numbers, 59. So if you now move to the 2 million city, we're going to start to go down. If we were at the peak, let's just say we dropped to 69. Is that still an attractive place to move to?
Yeah.
Yes. So now we're still having movement of this city's going to continue to shrink, and we're going to start to pile up. And we're going to continue to go this way on this curve. So this is going to be a stable amount. Eventually, it's going to equalize so that you're indifferent between the small city and maybe some of those other people went up, but we'll start to equalize with the number of cities. Okay, so that's the concept of this utility curve. So read this paragraph down here. So holding the 6 million thing constant where we're not allowing further growth, that's like how people would reallocate themselves, right, into the 2 cities, rather than here, even at the max. It'd be difficult. Okay, let's see. I think I was actually going to skip some of this. Okay, so let's just continue on with this. So small city. So now we can think about different city sizes. So we've got 1 million people on this side. So what is the side of the slope we're going to be on always? Is any city ever going to be over here? No. No. It's always going to be on that side. So we got a small city there. We've got a medium-sized city. and we got a large city with 6 million workers. What is going on with this? We got McDonald's or something, or why do we get this result here that 6, 3, 1, small, medium, large? But the one thing is they're all at this U star. What is U star saying?
Like optimal utility? Or in terms of how you view Starbucks?
Yeah, what was the dynamic that got us to that point? Eddie?
That they're indifferent between at that utility, they're indifferent between the small and
Yeah, they've got no reason to move. So kind of what I walked you through earlier with that other piece of kind of going to the big city and moving back. As soon as we get, people are going to keep going to the city, the city's congested, they have higher incomes, but those two things are offsetting. So some people would prefer to live in the small city, have less of an income, but no commuting costs, right? So all of those are kind of the equilibrating factors that is causing migration into the cities. All right, so where are we at on time? I didn't wear my watch today. Oh, look at that. You guys are getting out early.